Hello everyone, my name is Naman and this is my YouTube channel Scientific Curiosity. Now, in today's video, the topic that we are going to learn about is pressure in fluids and atmospheric pressure. Now, before pressure, we need to learn about thrust. What is thrust? If this is the surface and this is the force acting normally on the surface, then it is known as thrust. Therefore, thrust is the force acting normally on a surface. What is pressure? The thrust acting normally on a surface, the per unit area of the surface, is known as pressure. I repeat, pressure is the thrust per unit area of the surface. Now, what is the difference? Some may get confused. Thrust is only the force. This is only the force normally on the surface, whereas pressure is the force per unit area of the surface. Now, if this is a square, then the force acting on each and every part of the area of the square is known as pressure. Therefore, pressure is equal to force upon area. Pressure is equal to force upon area. Therefore, pressure is inversely proportional to area. Therefore, if you increase the pressure, in order to increase the pressure, you need to decrease the area. If you increase the area, the pressure will decrease. Larger the area, lesser the pressure, and vice versa. The SI unit of pressure is Pascal. It has been named after scientist Blaise Pascal, which is also equal to Newton per meter square. The SI unit of force upon the SI unit of area. Now let us learn about some examples of pressure. If you notice, when you sleep on a bed, the mattress doesn't sink that much. But when you stand on a bed, you notice a depression. Why this happens is because when you sleep, the same amount of force acts, but the area increases, so the pressure decreases. While when you stand, the same amount of force acts and the area decreases, so the pressure increases. The same thing is happening in this example. The brick covers a larger area, so it doesn't sink that much as compared to the brick covering a lesser area. If you try to hammer a nail into the wall, it will easily go inside. But if you try to hammer a pinball on a wall, you will see that it doesn't go, because the area covered by the pinball is much more larger than the area covered by the nail. Now let us learn about atmospheric pressure. The thrust exerted per unit area on the Earth's surface due to column of air is called the atmospheric pressure on the surface of the Earth. If this is the surface of the Earth and this is air in the atmosphere, then the force exerted by the air on the surface of the Earth is known as atmospheric pressure. Now, atmospheric pressure is measured by an instrument called barometer. There are many types of barometer: simple barometer, Fortin's barometer, and aneroid barometer. The most convenient one is the aneroid barometer. In the simple barometer, mercury is present and we need to carry it everywhere around, which is not very convenient. Now let us learn about some everyday examples of atmospheric pressure. When you suck a drink with a straw. When a drink is sucked with a straw, First, the air in straw goes into our lungs, due to which the air pressure inside the straw decreases. The atmospheric pressure acting on the surface of the drink, being more than the pressure inside the straw, forces the drink to move up into the straw, which then reaches our mouth. Now let's learn about the next example. Filling a syringe with a liquid. When syringe is kept with its opening just inside a liquid and its plunger is pulled up in the barrel, the pressure of air inside the barrel below the plunger becomes much more less than the atmospheric pressure acting on the liquid. As a result, the atmospheric pressure forces the liquid to rise up in the syringe. Action of rubber suckers. Rubber suckers are often used as hooks in kitchens and bathrooms. For this, rubber sucker is pressed hard against the wall so that the air between the sucker and the wall is forced out, creating a vacuum in between. The atmospheric pressure acting on it from outside then holds the sucker along with the hook on it firmly against the wall. For firm grip, the wall must be smooth. Now let us understand the Now let us understand the variation of atmospheric pressure with altitude. The atmosphere can be considered to consist of a number of parallel air layers. Now let us label this. This is layer 1, this is layer 2, this is layer 3. Each layer experiences a pressure on it due to the thrust of the air column above it. Layer 3 experiences the pressure of layer 2 and layer 1. Layer 2 experiences the pressure of layer 1. Therefore, as we go up, the height of the air column above us decreases, and so thrust exerted by the air column also decreases, which results in the decrease of atmospheric pressure with increase in altitude. Since the lower air layers get compressed due to the weight of the upper air layers, therefore, the density of air layers is more near the Earth's surface, and it decreases as we go higher and higher. The decrease in density with altitude is not linear. It is rapid at low altitude near the sea level and is slow at higher altitude due to decrease in density of air with altitude. The atmospheric pressure also decreases with altitude in a non-linear way. Now let us learn about pressure in fluids. A fluid is anything which can flow, so that basically includes gases and liquids. Now, a fluid contained in a vessel exerts pressure in all points and in all directions. If this is the liquid water, then each and every molecule of water will exert force in each and every direction. If these are the molecules of water, then they will force in each and every direction. Now, in liquid pressure, just like atmospheric pressure, the pressure increases with an increase in depth from the free surface, and the free surface is at the top, whereas the pressure increases as we go downwards. Now, because of which you can notice that the uh, if you make a hole inside a vessel containing liquid at the top, you will notice that the jet of water coming out is weak. If you make a hole below it, the jet will be stronger, and if you make a hole at the bottom of the vessel, then the force of the jet will be strongest. Because of this, the walls of dam are the thickness of the walls of dam is increased as the depth inside the water increases. Now let us know about Pascal's law. Pascal's law states that the pressure exerted anywhere in a confined liquid is transmitted equally and undiminished in all directions throughout the liquid. You can see in this example that this is a flask. It has a piston at the top. When the piston is pushed inside, a force is exerted, because of which the pressure is created and the water flows outside. If you will notice that the height of the water coming out of the pipes is same at all points, proving Pascal's law. Now there are several applications of Pascal's law. Now let us understand this. These applications are mainly seen in hydraulic machines. Now let us learn about principle of hydraulic machine. A small force on a smaller piston is transmitted to produce a large force on the bigger piston. If you will notice, this is a small piston. If you apply a small force, a pressure is created and the piston will go down. But on the other side, on this side, the piston is much more larger than the first piston, and in this the piston will rise, lifting any object that is present on it. This application of Pascal's law makes our everyday work much more easy. Now let us start with the first application of Pascal's law: hydraulic press. When a force F1 is applied on the piston A. Now this is the piston A, and if we apply a force F1 on this piston, then it exerts a pressure on liquid contained in the cylinder P. According to Pascal's law, this pressure is transmitted through liquid in tube R to the piston B of the other cylinder Q, due to which the piston B tends to move upwards. The piston B, that is this one, tends to move upward because of this force applied on piston 1. Since the area of cross section of cylinder P is less than that of the cylinder Q, therefore by applying a small force on the piston A, we can lift a large weight kept on the piston B. When no weight is placed on the piston B, it rises up against the fixed roof with a force F2. If a bale of cotton is kept on the press plunger B, it gets compressed. Now the uses of hydraulic press are for pressing cotton bales and good quality quilts, books, etc. For extracting the juice from sugarcane, sugar, beet, etc. For squeezing oil out of linseed and cottonseed. Now let us move on to the next example. Hydraulic jack. When handle edge of lever is pressed down by applying an effort, the valve V opens because of increase in pressure in the cylinder P. The liquid runs out from the cylinder P to the cylinder Q. As a result, the piston B rises up and it raises the car placed at the platform. When the car reaches the desired height, the handle edge of lever is no longer pressed. The valve V gets closed since the pressure on either side of the valve becomes same, so that the liquid may not run back from the cylinder Q to the cylinder P. Now let's go on towards the last example: hydraulic brakes. To apply brakes, the foot pedal is pressed, due to which pressure is exerted on the liquid in the master cylinder P. So, liquid runs out from the master cylinder P to the wheel cylinder Q. As a result, the pressure is transmitted equally and undiminished through the liquid to the pistons B1 and B2 of the wheel cylinder Q. Therefore, the pistons B1 and B2 get pushed outwards and brake shoes get pressed inside the rim of the wheel, due to which the motion of the vehicle retards. Since area of cross-section of piston A in the master cylinder P is less than that in the wheel cylinder Q, a small force is applied at the foot pedal, produces a large force on the pistons B1 and B2 of the wheel cylinder Q. This is the force responsible for retarding the motion of the vehicle. It should be noticed that due to the transmission of pressure through the liquid, equal pressure is exerted on all wheels of the vehicle connected to the pipeline R. On releasing pressure on the pedal, the liquid runs back from vehicle cylinder Q to the master cylinder P, and the spring pulls the brake shoes to their original position and forces the piston B1 and B2 to return back into the wheel cylinder Q. Thus the brakes get released. This is a working model of a hydraulic machine. This syringe changes the direction. This syringe increases the height. And this syringe lifts it up or moves it down. All this happens because of Pascal's law.